Let us understand data. We will define the term database, describe the role of a database management system, explain the difference between a relational and flat file database, outline the levels of the data hierarchy, describe the different data types, identify and apply the steps to create a simple relational database, and discuss the advantages of the database approach. Data is increasing worldwide because of the digitization of the world. Now, instead of machines and specialized people creating data or recording data, everybody in the world has become a data generator, particularly in the space of social media. So, which has given rise to large volume of data and in variety of forms at a very high speed or the high velocity. This deluge of data or this phenomenon is what we refer to as big data. We'll be focusing on very specific aspect of this data, which is the process of acquiring the data, storing the data, and transforming the data. In the process of converting data to information through input and output, the processor does the transformation, but that data that is acquired by the input needs to be stored and transformed in a suitable form that the processor can process. So let's understand what is a database. Database is the storage of the record in the hardware. It could be a solid state device or a hard disk. A database management system is a software for creating, storing, maintaining and accessing database files so that the users can engage with it. These databases come in variety of forms. Hierarchical and object-oriented models are very common, but the most popular among them is the relational databases. And relational database is the backbone of most of the applications that we see in the world today. This relational data model organizes data into interrelated tables, and they are much easier to understand compared to the flat file databases, which are not a collection of interrelated tables but a single table. So let's understand the flat file and understand why relational database is superior to it or important in variety of applications. So let us look at a flat file database where the names of the students are recorded and their major, email ID, course, grade, etc. is recorded in a single flat file. Now, the challenge with the flat file is following. If a particular student leaves the program or graduates, you have to find that student everywhere and delete the record of that particular student. Number two, every time a new record is created, there could be a spelling error in the way the name is recorded at different points of time. It could be capital, small, or there could be additional characters included in the name. So that creates the issue with the quality of data and error proneness of the information available in the databases. To overcome that, we split this information in bunch of tables whereby one piece of information is recorded only once. There is another challenge, that besides, let's say, the academic information, there could be information about financials and the personal information like the address of the student, etc. Now, not everybody in a university need to have all this information about the student. For example, a professor teaching in the class may not necessarily know the financial information about the student, or how the student is doing in the other courses, or who are the parents and where does the student live. So different people in the organizations might require a different piece of information about the student. It is difficult to manage and govern who gets to see which piece of information. So we try to resolve it by coming up with a new structure or an architecture which helps us address some of these challenges. So there is this piece of information where student name is recorded only once and the major recorded and the email recorded only once. And then the student ID is used to identify the courses that the student has taken and the grades that they have acquired. So here we kind of just map this student ID from one table to the student ID the other table, removing the duplicacy of records about a student in a flat file system. So that helps address some of those challenges. Also, different people in the organizations may be given access to different tables exclusively. Let's say professor can be given exclusive information about the grades and the courses that the student is taking with that professor, and the financial department might not know what the grades are. They only have the information about the financials of the student. Let us look at the hierarchy of data. So database is collection of records. Those collection of records are files. It's multiple pieces of documents which are used to build the database. Each of the files would have records, that is a single line entry of a particular object, and the attributes of those records are called as the fields that identify what's the name, what's the email address, what's the phone number, etc., etc. And these pieces, bits and pieces of information are nothing but bytes. Bytes are nothing but the collection of binary digits, which makes it easier for management and reading and interpreting. And binary digits are nothing but the 0 and 1 at the lowest level of granularity, which is what the hardware understands. So here we have the interface with the hardware. So bits are determined by the presence or absence of electrical signal, and database at this level, it is the interface of the humans who understand what information is there. So let's talk about the different types of data in the databases. We may define the fields to restrict the type of data it can store or acquire or record. So the different types of data are very obvious and simple as the textual data, and then we have the numeric data. These are the very basic forms of data, and we may have a yes, no, true, false, 1, 0 kind of data which is indicating presence or absence or agreement or disagreement, also called as the Boolean data. Then we have the specialized type of data called as the date and time, which indicates the time in the present or sometimes in future or somewhere in the past. Could be an appointment in the future, it could be the date of birth which has happened in the past, or when something is discussed or recorded. Then we have currency, which is nothing but number but with a special symbol prefix to the number to indicate that it means money. Then we have the paragraph text, which is a collection of textual data, and then we have the graphics, whether it's an image or some kind of a icon. And we can talk about more types of data like audio data, video data, and so on. So how do we design a database to record this information or this data? The first step in database design is data modeling. This step provides a high-level conceptual representation of the database structure. Data modeling includes capturing the entities, the objects or the people, relationships among those entities, and the degree of freedom or the restrictions or constraints on how these entities are related with each other. So once we identify it, we start building the database. The first thing that we need to identify is the primary key, and that primary key must be selected for each table, and this key is a unique identifier for each record in the table. Then we have a foreign key, is a field in one table that connects to the primary key of the original table. So let us say we have student ID, which is a primary key in the student table, but it's a foreign key in the grades table. And then we can kind of create the relationship between these keys to come up with a database. We have a concept of what we call as the database normalization. Normalization essentially means to design the database in a fashion that it reduces data redundancy and ensures data integrity. For example, the first normal form is also called as that one piece of information should be there in one field. That essentially means if there is a name, it only has the name in that field. We don't include the email IDs and the phone numbers in the same field. Now, by splitting the data into multiple tables allows us to implement the permissions, security, and remove any duplication or the errors. The databases help with the following: data accuracy. There are 6 levels of normalization which run from 1NF to 6NF, and there are some intermediate specialized normalization levels also. For example, BCNF, Boyce Code Normal Form, which address one of the aspect of the data quality and the data accuracy. We want to access the data as efficiently as possible. We want to ensure the integrity of the data, that we don't have spurious, unconnected, orphan data in the databases. Then we have data sharing. Multiple people might want to use, or some group of people access one aspect, another group of people access another aspect of the data. And finally, the security and the recovery, which is governed by the login password, and in case of a hardware failure, how do we recover the data? By creating duplicates of the data and regularly updating those data. Now, these databases involve variety of operations. So database manipulation is the use of a programming language to modify data in a database to make it easier to view or for the purpose of decision making. For example, you are looking at a student information system at a university. One, we may want to create a record for a new student enrolling or joining the university. We may want to remove the student from the system who has graduated or left the university. We may want to update the information about the student. What grades have they acquired? Have they changed their phone number or address, etc.? Or update their information of the financial payments, etc. Now, we have all these tasks to be done. For that, we need to engage and communicate with the databases. Initially, different database companies came up with their own respective languages to engage and communicate with the databases, but that created a different kind of challenge, that people working in one database need to be retrained again for the another database if they switch company or they have to work with another database. So the consortium of companies got together and they standardized the database programming language. And since we mostly query or question the database, the name adopted for that standardized common language to interact with the database is called as SQL, Structured Query Language, or often pronounced as SQL. So a database is an organized collection of related data. A DBMS is a software that is used to create and manage databases and can take the form of a personal DBMS used by one person, or an enterprise DBMS that can be used by multiple users. Relational databases are most widely used type of database where data is structured into tables and all tables must be related to each other through unique identifiers. Designing a relational database involves determining how the data is organized into tables, setting primary keys, and creating relationships among the tables. Normalization is the process of designing a database to reduce redundancy and ensuring the integrity. Database approach allows for the control of redundant data, data integrity, data sharing, security, and recovery. There are many data types and it is important to use the correct data type for a specific field. Thank you.